Hi, welcome back. In this video, you're going to learn about the different laws of radicals. I'm going to show to you how to derive the laws, and at the same time, I'm going to give examples how to apply the laws. Let's have a review about expression in radical form and how to write the radical form in exponential form wherein the exponent is a fraction. I have a video about this so you can watch also. Okay, so here n is what we call the index and a is what we call the radicand. Now, we can write this in exponential form, and that is equal to a raised to 1 over n. Now, look at this. The index n is the denominator of the exponent, always, and understood there is 1 here as the exponent of the radicand, and that's the numerator here. Okay, now, that is now the exponential form. If we have this given now, which means that the exponent of a here is no longer 1. So we can write this as a raised to m over n. So still, the n here or the index is still the denominator and the exponent here is the numerator of the exponent. Now, so let's have an example on how to rewrite. I have square root of 2 and understood that if it's square root, the index here is 2. So we are not writing that anymore. Understood. If there is no index, that's 2. And that is 2 raised to 1/2. So the 2 here, the index 2, that's the denominator. And understood there is 1 here, and that's the numerator. If it's 1, we are not writing that also. Now, if I have here cube root of 2, means that this index, that's the denominator, and there is 1 here, so that is 2 and 1/3. And then I have here square root of 2 raised to the 3rd power, which means that the base is 2. Okay, the base here is always the radicand, okay? Don't forget about that. That is now 2 raised to 3 over 2. Why 3 over 2? Because understood the index here is 2, it's square root, and then the exponent here is 3. Okay, now what we're going to do is we're going to derive the laws of different laws of radicals, and we're going to give an examples on how to apply those or these laws. Now, let's start with this one. I have here the cube root of 8. When we say, what is the cube root of 8? You are looking for the number that if you're going to raise to 3, the answer is 8. It means what number that if you're going to multiply 3 times, the answer is 8. So the number is 2. 2 times 2, 4 times 2, that is 8. 4 times 2 is 8. Or that is 2 raised to the 3rd power, or 2 cubed. It means that 8 is the same as 2 cubed. Now, if we have this one, the cube root of 2 raised to the 3rd power, let's rewrite this in expression with rational exponent. That is the same as 2 raised to 3 over 3. Remember, the index is the denominator and the exponent is the numerator. And now that this is 2 raised to 3 over 3, and what is 3 over 3? That is equal to 1. So simply, the answer is 2. Now, if I have here the cube root of negative 3 raised to 3, it means that in expression with rational exponent, that is negative 3, then again, that's the index, the denominator, and this is the numerator. Again, 3 divided by 3, that is 1, so the answer is negative 3. Understood, there is exponent 1 here also. But if it's 1, we are not writing that anymore. Understood. Now, I have here the 5th root of negative 10 raised to the 5th power. So again, We can write this in expression with rational exponent, that is negative 10. That is the index. And this is the numerator, the exponent here. And the answer is simply negative 10. Now, you look at the answer now. This is negative 2. This is 2, which is simply the base here in the radicand. Negative 3, this is the base here in the radicand, and negative 10, that is the base here in the radicand. In general, if we have the nth root of a raised to n, wherein the index and the exponent here is the same number, that is equal to simply the base, or a, here. Now, what have you noticed here about the n, or the index, and the exponent? They are the same, and also they are odd numbers. 3 is odd numbers, 5 is odd number. Now, this condition is true if n is odd number and a is not equal to 0. So it means the answer is a, the base here of the radicand, if n is odd number. Okay? So let's have an example. I have 7th root of 5 raised to 7. Now simply, I'm not going to do like this anymore. I can just simply write my answer as 5. It's easy, right? If I have the cube root of negative 15 raised to the third power, the answer is simply negative 15. That's how convenient the laws of radicals. This is just the first law, or law number 1. It means more to go. Now, what happens if this is not odd number? Let's say if this is even number. Let's say 2, 4, 6, or 8 as the index and the exponent. So let's see. So here, I have here the square root of 4. Square root of 4, understood the index here is 2, right? And it means what is that number raised to 2? The answer is 4. Or what number multiplied 2 times that the answer is 4? So the number is 2. Or simply, we are going to rewrite this in exponential form. That is 2 squared. Now, understood? Here, the index is 2. Which means we can rewrite this in expression with rational exponent or fraction as the exponent. That is 2 raised to, or 2 raised to 2 over 2. So that's the numerator. This is the denominator, which is the index here. Now, the answer there, because we know that 2 divided by 2 is still equal to 1. So copy the base 2, and understood there is a 1 as exponent here. Okay, so now you notice here, still the answer is 2, the base. This is even number. Now, is it still true if the base here is negative? The base here is positive. What about if the base is negative? We still have the index as even number here. Now, in this case, wherein the n here and the index here is even number, it means by negative 3 raised to 4, it means that we are multiplying negative 3 4 times, right? Negative 3 times negative 3, that's positive 9. Positive 9 times negative 3, that is negative 27. And negative times negative, that is positive. So the result here, because it's even number as exponent, will always be positive. So what happened now? So since we're going to get the fourth root of that, that is 81, right? If we're going to expand this one, means finding the fourth root of 81, what number? So the answer is 3. 3 raised to 4 is equal to 81. And the base here is negative 3, and our answer is 3. It means in order to get the final answer, if this is even number and this is negative, is to get the absolute value of the base. So negative 3, absolute value of negative 3, that is equal to 3. Now, the continuation of law number 1, if we have an nth root of a raised to n, that is equal to the absolute value of a, which is the base here, if n is even number and a is less than 0. What does it mean that a is less than 0? What are numbers less than 0? They are negative numbers. So, for short, if n is even number and a is negative numbers or negative number, we need to get the absolute value of a. So, let's have an example. So, if I have the 6th root of 5 raised to 6, simply, the absolute value of positive 5 is simply 5, right? But if it's positive, we are not writing the plus sign anymore. So it's okay if it's positive. Now, if we have the nth root of negative 15 raised to 8, it means the answer is 15. Getting the absolute value is simply removing the negative sign. That is 15. So again, this is law number 1. So the other one, if n is odd number, and this one, if n is even number. So let's have another one here. So we have the law number 2. I have here the nth root of a raised to m. It says that it is equal to the quantity of the nth root of a raised to m. So what's the difference between these two? Here, you are going to raise to a power first before getting the nth root. While here, you are going to get the nth root before raising to a power, which means that they are just equal. So let's prove that. Okay, so now I have the nth root of a raised to m. If I'm going to write this in expression with rational exponent, that is a raised to m over n. Remember, this is the index and this is the exponent. What about this one? It means there is 1 here as exponent, right? So I can get first the expression in rational exponent, the one inside the parenthesis. And that is equal to a raised to 1 over n. The n here is the denominator and the exponent 1 is the numerator. Then I'm going to raise to m. Now, if I'm going to raise to m, it means I'm going to distribute this. 1 times m, that is still m, divided by m. So that is still equal to a raised to m over n. So they are equal. So if you're going to put this outside the parenthesis, you don't have problem. You will get the same answer. So here is an example. So I have here the square root of 9 squared. So understood, there is index of 2 here, right? Which means even number, the same. The answer is simply 9. While here, I am going to get the square root of 9. What is the square root of 9? What number you're going to raise to 2? The answer is 9. That is 3 times 3, right? Or the square root of 9 is equal to 3. And then square that 3. 3 squared means 3 times 3. That is still equal to 9. Okay? So you'll get the same answer. That's the law number 2. Now, let's have law number 3. I have here the nth root of a times b. So it means here, we have a product here. Okay? Now, it says that that is equal to the nth root of a times the nth root of b. It means you can separate them into 2 factors. Okay? Then you can multiply them. The same index, of course. So let's have an example. Let's say I have the square root of 8. So I can rewrite square root of 8 as 4 times 2, right? 4 times 2, that is equal to 8. Why I choose 4 times 2? Because I know that this is square root and 4 is a perfect square. Therefore, I'm going to use this one. And I can rewrite this as 2 squared. And then this is 2. So now, I can apply now the first law of exponent that we have here, the same index and the same exponent. It means the answer is simply the 2. So I can bring out the square root of 4, which is 2, outside the radical form. And since 2 is already in simplest form, we can't think anymore of a number raised to 2 that the answer is 2. So therefore, remain inside the radical sign. So that's the final answer, 2 square root of 2. Now, how are you going to find for two numbers that one is, let's say, a perfect square, a perfect cube, or a perfect fourth root? Okay? How can you find that? So simply, if you know how to use factor tree, factorization, you can do that. 4 times 2. And then you can simplify this. That is 2 times 2. It means that 8 is equal to 2 times 2 times 2. Since this is square, the index here is 2. It means you're going to get one pair. Okay? It means that that is 2 squared. That is 2 squared times 2. That should be the one inside the radical sign. Like that. So you can simplify this one, since this is also the index is 2. So understood, the answer is this one. So you can bring that outside the radical sign, 2. And since 2 has no partner to make it a perfect square, it's not a perfect square, so you can write that inside the radical sign. Okay, let's have more example. So I have here cube root of 81. So now, 81. Okay, let's do this one. So what numbers you can have for 81? Okay, let's have 9 times 9, 81, right? And for 9, we have 3 times 3. And then also here, we have 3 times 3. It means that I am just going to, so we have now 3 times 3 times 3 times 3. And since this is cube, I'm just going to have here 1, 2, 3. It means 3 cube. And this one is remaining, which is not a perfect cube. Which means that 81 is equal to 27 times 3, or that 27 is equal to 3 cube times 3. Okay? You can put it like this, or you can write it like that first, or you can direct it using this factorization that I showed here. Now, since this is cube here, which means we can cancel this one now. Or simply, since the index and the exponent is the same, the answer is just simply this one, applying the first law of exponent. So that is now 3 outside the radical sign, and this one, since this is cube and he has no, this is not a perfect cube anymore. When we say perfect cube, it should be 3 numbers. Okay? So you can put that inside the radical sign. And that is 3, the final answer now is 3 times the cube root of 3. That's law number 3. So let's have here law number 4 on our list. So I have here, you notice the radicand here, a quotient or A divided by B. So the nth root of A divided by B, or A over B, is equal to the nth root of A divided by the nth root of B. It means you can separate the numerator and the denominator, but they are of the same index. Okay, so they are just equal. So let's have an example. So it means if we have the square root of 5 over 4, I can rewrite that as a square root of 5 divided by the square root of 4. And then I can simplify the numerator, and also I can simplify the denominator. Now, in the numerator, square root of 5 is not a perfect square, which means this is already in simplest form. So I'm just going to copy that one, square root of 5. But 4 is a perfect square, and the square root of 4 is 2. So I can simplify that. So the answer is square root of 5 over 2. Now, I have here the fourth root of 25 divided by 81. So I can separate this, the fourth root of 25 divided by the fourth root of 81. Now, 25 again is not a perfect root for this index 4, which means that there is no number raised to 4 that the answer is 25. It means that's already in simplest form. So that is the fourth root of 25 divided by, but 81, there is a number that raised to 4 is equal to 81. And that is 3. 3 times 3, 9, times 3, 27, times 3, 81. So 4 times. Okay, that is equal to 81. Or 3 raised to the 4th power. So what number raised to 4 that the answer is 81? So the answer here is 3. So that is the denominator 3. So the final answer now is the fourth root of 25 divided by 3. Now, in my next video, I'm going to show to you if in case that the denominator here is not a perfect square, a perfect cube. Okay, it means we're going to have a square root in the denominator. And we are not allowed to do that to have the final answer wherein the denominator has a radical sign. So we're going to learn about that. That is rationalizing. So that would be on the next video about simplifying radicals. Now, in this case, I only showed about this one because what is important here is just how to apply the law. And we have the last one here. This is law number 5. So here I have the nth root of the nth root of A. So you have two radical signs here, which means that you can write this as multiplying the index m times n. The index here of the bigger radical and the smaller here, or the one inside the big radical sign. You can multiply this too. And then that is the square root of A. Let's have an example. So I have here the cube root of the square root of 729. Again, the cube root of the square root of 729. So which means that the index here is 2. So I can multiply them. So that is 3 times 2, which means that the index now is equal to 6. So I have now the 6th root of 729. What does it mean now? What number raised to 6? The answer is 729. Okay? And that is 3 raised to 6. So multiplying 3 6 times will give you 729. So now, of course, the index there is 6. We can now apply the first law of exponent. The same index here. It means the answer is simply this base, and that is equal to 3. So see, look at this. The cube root of the square root of 729 is equal to 3. Okay, let's have another example here. This time, what we're going to do first is, let's just take perform first the inner square root and the outer square root here. This is just a square root, just to prove that you will get the same answer. What is the square root of 16? Because this is easy. The square root of 16 is 4, right? In the inner part, we already extracted the square root, which means this one is gone. And we have now the outer radical sign. Again, what is the square root of 4? For this. And that is 2. It means that the square root of the square root of 16 is equal to 2. Or you can simply multiply 2 here index, we have 2 here. Or we can rewrite that as the fourth root of 16. So it means what number that you are going to multiply 4 times, the answer is 16. Or what number raised to 4, the answer is 16. And that is equal to 2. 2 raised to 4 is equal to 16. And now applying now the first law of exponent, we have here the same number. Therefore, the answer is simply the base. That is equal to 2. Now, that's how you're going to apply the different laws of radicals. Thank you for watching and see you on the next. Please watch the next video about simplifying radicals. Bye!